next lecture on database management systems, in which we will cover the mapping of the entity relationship diagram and the extended entity relationship diagram into relations. We have already covered the entity relationship diagram and the extended entity relationship diagrams. So, the next step would be to cover these into tables or relations, so that we can actually start using the database. So, a logical database design, we have already said, is to create the relational schema, and this relation schema we will create from the ER and the EER model. That is, what we will do is that we will map all the entities, the attributes, the relationships, generalizations or specializations and the aggregations into relations. So, first let us start with the mapping of the regular entity type. In the mapping of the regular entity type, I have shown here the entity type employee with the attributes employee number, name, date of birth and a composite attribute with the simple attributes house number, street and city. If you remember, I had told you a composite attribute is an attribute which can be broken into parts. So, now to map such a regular entity type, we will make a relation with the name of the entity and we will include all the simple attributes, that is ENO, name and the date of birth, and for the composite attribute we will include only the atomic or the simple attributes. That means, we will not have the address here, we will instead have house number, street and city, and then we will underline the primary key which is given in our ER diagram over here in the relation. So, this is how we will map a regular entity type. Next, let us take up the mapping of a weak entity type. A weak entity type, let us quickly review, is an entity type which does not have sufficient attributes to form the primary key. So, a weak entity type, it uses its partial key or the discriminator and borrows the primary key of the corresponding strong entity type to form the primary key. Now, to map a weak entity type, that is, we have the weak entity type dependent over here with the attributes name, sex, birth date and relationship, and name being the partial attribute, we have shown it with a dotted line. The corresponding entity type or strong entity type on which this weak entity type depends is the employee with its own attributes and the key SSN. Now, we will map employee as a regular entity type, which we have done over here, and for the weak entity type we will create a relation with all the attributes of the weak entity type, that is, we have name, we have sex, we have relationship and we have birth date, and in addition we will include the primary key of the corresponding strong entity type as a foreign key. So, this over here refers to this ENO over here, which is the primary key of employee, and the primary key of the weak entity type dependent will be the combination of name and ENO. So, the primary key will be name plus ENO, name being the partial key and ENO being the primary key of the strong entity type. Now, let us do the mapping for the binary relationship types, that is, the relationship types which have two participating entity types. We will do it for 1:1 relationship types, 1:n and m:n relationship types. A 1:1 relationship type, if you remember, is a relationship type that if we have two attributes, we have two entity types A and B, then we say that an occurrence of A can be associated with only a single occurrence of B and an occurrence of B can be associated with only a single occurrence of A, right. This is what a binary relationship, binary 1:1 relationship is, which we have done earlier also. Now, when we need to map a binary 1:1 relationship, then we have two ways of doing it. A foreign key approach, when one of the entity types, one of the participating entity types has a total participation. A total participation means that all the instances of B which has a total participation shown by a double line will participate in this relationship type. Whereas a partial participation means that all the occurrences of A may or may not participate. So, we will use the foreign key approach when one of the participating entity types, it has a total participation, and we will use the merged relationship approach when both the participating entity types, they have the total participation. Let us look at the foreign key approach. So, here we see we have the relationship manages between employee and department. It is a 1:1 relationship, employee manages department, and we have shown over here that department has a total participation. So, participation of department is total over here. Now, what we have done is that for the entity type which has the partial participation, we are showing it as a regular entity type with its attributes. The entity type which has the total participation, what have we done? We have included the attributes of it, that is DNO and DNAME. Then we have included the primary key of the entity type with the partial participation as the foreign key. This shows it is a foreign key, and in case the relationship type has a attribute, then the attribute of the relationship type will be included in the entity type which has the total participation. So, this is how we will take up this approach. Now, let us have a look. Let us say I have the ENO numbers as 1 and 2 and the name as Amit and Ajay, and I have the departments as D1 and D2, DNAME as let us say CS and EC, ENO such that ENO 1 manages D1, ENO 1 also manages, let us have another one 3, Sumit, and there is another department D3 which is managed by D2, let us call it civil. Let the start date be anything. Okay. So, that means if these tables are populated, this is something that this will look like. Now, you may ask me that why could we not have DNO, that is the key of this over here, and also the start date. Why could we not do this? That means not having these two here, but having them here. So, this means ENO 1 we know is managed by D1 is managed by ENO 1. So, ENO 1 manages D1, D2 sorry, ENO 1 also manages D2 and ENO 2 manages D3, right. Now, you tell me, can I show this over here? No, I cannot, because in a single cell we can have only one value. So, we do not have a way to show how ENO manages D1 and D2, and hence we will see that we will do it the way we have done, that the total participation site will contain the primary key of the partial participation site as well as the attribute of the relationship type if it exists. The second method was the merge relationship approach, when both the entities they have a total participation. So, over here we see that both the entities over here have a total participation. So, in this case what we will do is we will have a merged relation approach. That means we will merge all the attributes of the participating entity types as well as the attribute of the relationship type into a single relation, and the key of that single relation can either be the key of this over here, that is employee, or it can be the key of department. So, this is what I have done: ENO, ENAME, DNO, DNAME start date. Key I am taking of the employee, ENO, ENAME, DNO, DNAME start date. The key is that of the department. Next, we take up the mapping of binary 1 to n relationship types. What is a binary 1 to n relationship type? That an occurrence or instance of A can be associated with any number of instances of B, and an instance of B can be associated with only one instance of A. Similarly, we can have a n:1 relationship where an occurrence of A can be associated with one occurrence of B, and an occurrence of B can be associated with any number of occurrences of A. So, here also we have two methods. First method is include the relationship attributes on the n side, in this case now here entity type in the foreign key approach that we have just done, or the cross reference approach. We can use any one of these, and this is irrespective of total or this is irrespective of total or partial participation of the participating entity types. Let us see an example over here. Here we have employee and department 1:n. So, we are saying include the relationship attribute on the n side entity type. N side is which? Department. So, relationship attribute comes on the n side entity type, and the primary key of the one side is put as the foreign key on the n side, right. Now, let us see again, we have employee 1, 2 and 3. Let the names be Amit, Sumit and let us say Ajay. We have the departments D1 and D2, DNAME, CS and EC. Now, we say that ENO 1 जो है ENO 1 from here manages D1 and also ENO 1 manages D2 on some start date. Right? This is the scenario we have and it is perfectly fine. Now, we could have said that let us put start date here and let us put DNO here. So, let us see what happens. 1 manages whom? D1. So, we have D1 over here and we put a start date somewhere here. Then also 1 manages D2 and we put whatever the start date, and for D3 there is no one who is managing. So, what will we do? We will put a null and we will put a null over here. So, what will happen is that in this case, in this example I have shown you only 3 employees and 2 departments, but obviously in a real scenario the number of departments as well as the employees will be much more. So, we will end up, in case we do it the way I have done a second time, we will end up in a large number of null values, and null values, they are not desirable in a good relational schema design. So, that is what we say, that we will have this foreign key which is from the one side, and we will have the relationship attribute if it exists on the entity type with the n on the n side. The second approach I told you, here also we said we can have two approaches. The first one we have already done, and the second one is the cross reference approach, that is form a third relation consisting of the primary keys of both the entity types. Form a third relation which is consisting of the primary keys of both the relationship types, and along with that the primary key of the relation is the key attributes of the n side entity type. And thirdly, because we are saying we are forming a third relationship, so in this case the relationship attribute will go to the new relation that we have formed. So, over here we have a 1:n. Same example, employee manages department. So, employee like a regular entity type, DNO like a regular entity type, and we have a third relation which is, instead of this works for, we can write manages. Third relation manages, which contains DNO, which contains ENO, and which contains the start date, which is the attribute of the relationship type. So, this is how we will do. The key will be which one? We said the key will be the key of the n side entity type. So, this is the relation that we will get in the cross reference approach. Next is mapping of the m:(n) relationship types. M:(n) relationship type means A any number of occurrences of A can be associated with any number of occurrences of B, and any number of occurrences of B can be associated with any number of occurrences of A. This is called a m:(n) relationship type, and the approach that we use for mapping a m:(n) relationship type to a relation is the cross reference approach. We just said a cross reference approach means form a new relation with the key attributes of both the participating entity types and the relationship attribute, right. The primary key of the new relation will be now the combination of the primary keys of the participating entity types. So, let us have a look here. This is a m:(n) relationship type. Employee can work for any number of departments, and a department can have any number of employees. Ours we have as the attribute of the relationship type, right. So, what did we say in the cross reference approach? Form a new relation with the key attributes of the participating entity types. So, key attributes of the participating entity types, employee and department, and the attribute of the relationship type if it exists. This is the attribute of the relationship type, and what will be the key? The key will be ENO plus DNO, that is the key, the combination of the keys of both the participating relationship types. Next, if you remember what recursive relationships were, a recursive relationship is a relationship between the same entity type. So, we have this recursive relationship supervision, which is a relationship of employee with employee, where the employee is serving two different roles. One of the roles of employee is that of the supervisor, and the second role of the employee is that of the supervisee. That means a supervisor can supervise n employees, and a employee can be supervised by only one supervisor. So, whenever we have a recursive relationship, because a recursive relationship is a relationship between the same entity type. So, in this case we will have employee with its attributes ENO and name. The key will be ENO, which is the key of the entity type, and we will have a super ENO, that is super ENO over here means the ENO of the supervisor. It is the ENO of the supervisor. So, when it is the ENO of the supervisor, so we will have it here, and this will be as a foreign key to the primary key of the employee. For example, let us say I have the employees E1, E2, E3 and E4 with their names So, I can say that super ENO E2 supervises E1. For E2, let us say there is no supervisor. For E3, the supervisor is E1, and for E4 also the supervisor is E2. So, that means this is the what foreign key? It is, where is it deriving its value? It is deriving its value from the primary key over here. So, this is how we map a recursive relationship to a table. Now, let us look at the mapping of the multivalued attribute. What is a multivalued attribute? A multivalued attribute is an attribute which can have multiple values. For example, over here we have the entity type department, and locations is a multivalued attribute. So, when we say locations is a multivalued attribute, that means the department can have more than one location. Say a department is there situated on the ground floor and the first floor. So, now let us say if I try to map this as a regular entity type, then I will have the attributes number as the key, name and locations, right. So, let us say the departments are 1, 2, 3 and 4. 1 is CS, 2 is EC, 3 is EN and 4 is, let us say, civil engineering. Now, the department CS or the department number 1, it has the locations on ground floor and first floor. This is only on the first floor, this is only on the second floor, and this is on the first floor and the third floor. So, now since location is a multi-valued attribute, it will have multiple values. How do we show this? Because we cannot do it over here the way I have done it, we cannot have more than one value for a attribute for a particular tuple or row. Hence, this particular representation or mapping is not correct. Instead, for the multi-valued attributes, what we do is we make, for the entity type, we use all the attributes which are not multi-valued like this, number as the key and name, and for the multi-valued attribute we create another relation with the key and the location. So, now let us say if I have 1, it has a location on ground floor, 1 has a location on first floor, 2 has a location on first floor, 3 has a location on second floor, 4 has a location on first floor, and 4 has a location on third floor. And what will be the key for location? The key for location will be number plus location, because we can't have number alone, we are having 2 rows with 1, we are having 2 rows with 4, but this is unique, 1 GF, 1 FF, 2 FF, 4 FF, 4 TF. So, we will separate the multi-valued attribute into a new relation. Next, we will do the mapping of the specializations and the generalization. Specialization or generalization means that for a superclass, in a superclass we include only the common attributes, and in the subclasses we include the specialized attributes. Now, whenever we have a generalization or a specialization, then if we say that C is the superclass, S1, S2 and so on are the subclasses, K, A1, A2 they are the attributes of the superclass, where K is the primary key of the superclass. Then for the superclass C, create a relation C with the attributes, that means all the attributes of the superclass and the primary key K, and for each subclass that is there, create a relation Si with the attribute K, that is the key of the superclass, union the attributes of each of the specialization and the primary key. So, this is what is here. We have employee as the superclass, we have the subclasses as secretary, engineer and technician. The common attributes are ENO and name. The specialized attributes are typing speed, pay scale and grade. So, what we have done is that, like we said, for the superclass you create a relation with all the attributes of the superclass. So, we have put ENO and name over here. We have the 3 subclasses secretary, engineer and technician. For each subclass, use the key of the superclass, use the key of the superclass and the special attribute of the subclass, which in case of the secretary is the typing speed, which in case of the engineer is the pay scale and which in case of the technician is the grade. So, this is how we will do the mapping into the relations for specializations and generalizations. Now, aggregation. What was aggregation? Aggregation means that when we cannot have a relationship with a relationship, we want to show a relationship between 2 relationships. When we are not able to do, then we use the concept of aggregation. Aggregation combines a relationship between 2 entity types into a single high level entity type. So, if this is a single high level entity type, then we can have a relationship with some other entity type. This is what we had done, what an aggregation is. Now, to map the aggregation into the relations, what we will do is that for each of the entity types that are existing, we will simply use them as regular entity types. So, project is PNO, PName, employers ENO, EName and machinery is MNO, MNO, MName with the respective keys. Now, for the relationship works for, we have already done. How do we map a, this is we have shown over here is a M is to N relationship. How do we map a M is to N relationship? PNO, ENO, that is the primary key of both the participating entity types into a new entity type. This is what we have done. What will we do for require? Again it is M is to N. So, the PNO, ENO and MNO, that is this will be the key, that is from all the 3 entity types that are there plus the attribute of the relationship types, and the key will be PNO, ENO, MNO. This is how we will show the mapping of the aggregation into the relationships. So, this is all that we have in the mapping of the different types of entities, attributes, relationships and the extended ER features into the relations. These are the reference books for reading these topics. Thank you.